So I'll explain then a bit about how these paper analytic devices work. So what they are is so this is one we haven't finished making. It was partway through the manufacturing. They are literally pieces of filter paper, very similar to coffee filters or so on, and they've been printed with wax ink. So these areas, these coloured areas are wax, and what that means is that if you put a water-based material in the areas, they stay there. So you can think of each of these areas as being like two-dimensional beakers or reaction vessels. So in a traditional lab, we do our chemistry in beakers and reaction round bottom and flasks. And what we've done is we've replaced those three-dimensional glass vessels, glass containers, with two-dimensional containers. So what this means is we can put in each of these circles different chemicals, different compounds. And what we've done then is we've added compounds in each of these two areas that then react with phosphates. So what happens is we take these, we add the compounds to these areas, they get folded in half during the manufacturing process, and that means that the compounds on this side and this side are almost in contact with each other. And then when you add water to them, the water allows the two compounds to mix, and then when they're in the presence of phosphate, these areas change color. So the manufactured devices then look like this. Yeah. So they are now in plastic laminate. So they're just used a normal office laminator, and on the back you'll be able to see this when you have a look at them in more detail in a minute. You'll be able to see that there are these slits in there. So when we use these, all you have to do is you take them and you drop them into your water sample. Okay. So I'll show you them then in practice working now with a stock solution I have of phosphate. So this is this one here, as I said. All you do then to use them is you take the device, you just bend them a little bit because that opens up the slits, and then you take your sample. So this would normally be your sample that you've taken from the waterways, but I've got a concentrated phosphate solution, which also happens to be called Coca-Cola. And this so imagine this is your river water in your Petri dish here, and all you do is you take this and you drop it in the water in your sample. Now, as you do that, and I'll show you that in a minute, as you do that, the water or your cola or whatever starts to enter those slits on the back of the device. So you might just be able to see this, and you'll have a go at this in a minute. I'm going to try not to drop Coke on my but some of these circles have now got some of the Coca-Cola entering them, and we leave that there for 3 minutes. So that's the length of time it takes for the phosphates in the sample to react with the material in the device. And over the course of 3 minutes or so, a color starts to develop in these pads. Now, when we designed this, 3 minutes, we thought that was a nice short amount of time. It turns out that 3 minutes standing on the side of a riverbank in northern England in January is a really long time, actually. But you know, so keep moving if you're doing this. Anyway, so over the course of 3 minutes, these start to react, and the areas then start to go blue. So this is just starting to do that now. Just a minute, I'll give it a minute or so more. dry it off again. So you might be able to see now that some of these areas have got a blue tinge to them. Yeah. So that's because that's the device is reacting with the phosphate. Now, what you'll see on this device also is that we've got two here that haven't changed color. That's normal. These areas are known as our control zones. So these are not supposed to change. They are there so that we can actually see what the color of the water actually is, and we can remove that from the colors when we analyze it back in the lab. You can also see maybe that the other 6 areas then are absolutely identical. They should all go eventually the same color, but we know from experience that sometimes some of the areas don't open up as well as the others, and that's why we've got 6 repeats there. So in case 1 or 2 of them don't work so well. So that is all that you need to do to measure use these to measure the phosphate samples in the water.